Hi everyone, welcome back to our channel where we discuss everything IGCSE Mathematics. So today we will be going through the entire additional mathematics paper 1 taken from the year 2022. The month is a May-June paper. The code number for this paper I believe is 0606/11/M/J/22. So before we start, just note that this PDF file of this handwritten solution is available for download from our website. Please do download it if you need some sort of reference as we go through this paper together. And also please share and like this video if you find this video useful, and consider subscribing to our channel. So without further ado, let's see how we can actually do this paper here proficiently. So let's look at question 1. Find the constant ABC. I think this is pretty okay. What we're going to do is we're going to start from the difficult side, which is the left hand side, right? So we're going to rewrite this. This is root. Root is just means that this is p to the power of half. Okay, that's about it. Then q, this is q to a third, and then after which this is r to the power of -3 divided by this. We could just multiply in, right? Just distribute it in. So this is p. Remember this is 1 here, so 1 multiplied by 2 would be 2. Q, -1 multiplied by 2 will be -2. Then this is r, -1. Alright, so once this is done, this is pretty okay. What we're going to do is just remember, with the same base, we can group them together. So this is actually just p half, it's divide, right? So half minus 2, after which the other one will be q, 2/3 minus -2. Just remember the bracket. The problem with not bracketing is it will cause a lot of careless mistake, right? So just 2/3 minus -2. Just remember that. Then after which we got the last one, which is r, -3 minus -1. I think this is pretty okay. So once done, half minus 2, that will give us -3/2. This would be 8/3. 2/3 plus 2 will be 8/3. Then after which the last one will be r, -2. So in this case there, what we have is hence a is equals to -3/2, b is equals to 8/3, and c is equals to -2. So a is equals to -3/2, b is 8/3, and c is -2. Alright, so that's how we do this part here. Let's look at question 2. So a particular moves in a straight line such that its displacement s meter from a fixed point at time t second is given by this expression here. Find the exact speed of a particle when t is equals to 1. Now speed is not velocity. So what you need to understand is the speed, exact speed, meaning to say I need the magnitude of the velocity, which is v. Okay, at t equals to 1. So this is when t equals to 1. I just need the modulus of it. Alright, so that's the main thing. So I think we just find this is the displacement, right? So dt, half. So ds dt will just be our velocity. So this will be -half. Then after which 1/3. This is called the chain rule, right? So the outer layer, then after which the inner layer. So just remember, you differentiate the outer layer, you get this. This will multiply to the front -1. Now you multiply by the derivative of the inner layer, which is 3. Okay, so what we get is -3/2, 1 plus 3/t, -3/2. After which what we get is we need t equals to 1. So I think t equals to 1 is pretty okay. We just put t equals to 1. Velocity will just be -3/2, 1 plus 3, which is actually 2, square root 2. So it's -3/2. This is 4 root, so it's 1/8. Be -3/16. Alright, so the answer would be the speed. Speed will just be 3/16. What's the units that we got? Meters, right? Meters per second. So this is speed is meter per second. That's great. So show that the acceleration of particle will never be 0. I think this is pretty okay. So similarly, I'm going to put from v, so acceleration will just be dv dt. So same thing. So maybe I just rewrite my velocity here so that we're all on the same page here. So bracket the outer layer, then you differentiate the outer layer and inner layer. In this case, there will be dv dt will be negative 3 over 2 minus 3 over 2. 1 plus 3 over t minus 1 will be negative 5 over 2 multiplied by 3. Okay, so the outer layer derivative will be this case there. You multiply it down, then minus of 1 from the power. Then you differentiate the inner layer with 3. Okay, I think overall what you get is actually 27 over 4. 1 plus 3t negative 5 over 2. We are told to show that this will never be 0. Okay, so I think the acceleration, write it down. So what we need to know is essentially look at this, because the one which is gonna make it positive or negative solely depends on the variable part, which is the one which involves the t, right? This is already always positive, so we know that okay, one essentially what we can just 3t, this is minus 5 to the power 5. Okay, square root. Sorry. So this is 1 plus 3t minus 5 over 2 would just be, so maybe I just move this. This is actually square root 1 plus 3t power 5. Okay, so we know that this essentially, we know that what we can write down is since square root 1 plus 3t is actually at least 1 bigger than 0. Right, then power 5 is obviously, if we power 5 it, it'll be bigger than 0. So when you take the reciprocal, which is actually 1 over square root 1 plus 3t to the power 5, it's also still bigger than 0 because it's positive. So essentially what we can get is multiply 27 over 4. So this case there will be multiplied by 27 over 4. Okay, 27 over 4. Then this is 1 over 1 plus 3t to the power 5 bigger than 0. So this part is always bigger than 0. So that's why this, okay, I think I'm just over explaining things. You could skip this step, I believe. So then this is just a. So hence acceleration is just bigger than 0. Okay, shown. Acceleration is just bigger than 0. That's how you do this part here. Alright, so the next thing is the function f is defined as such 0. Okay, so we know the vertical asymptote is x equals to 2x plus 1 equals 0. So the vertical asymptote will be negative half, right? Write down the range of f. So the range of f will just be from negative infinity to infinity. Right, that's about it, the range of f. Or we could write it as fx is an element of the real value. Okay, that's the range. Fx is the range. So that's about it. So function g is defined as gx is 5x minus 7 for x, for all real value of x. Find the exact solution for g of x equals to 13. Okay, so this is interesting. So in this case here we have fx equals to 13. What I'm going to do is essentially going to just replace my fx in it, because my fx is ln. So I could see this as like that, right? So I'm actually putting g ln 2x plus 1 into the function of g. So ln 2x plus 1, now I treat this as an element, as an input x here. So this case there, I'm going to just put this as 5 ln 2x plus 1 minus 7 equals to 13. So find the exact meaning we can't use calculator. So this case would be 13 plus 7 divided by 5 is my ln 2x plus 1. This would be 20 divided by 5, which is 4, right? So 2x plus 1 is equals to e to the power 4, and then x will just be e to the power 4 minus of 1. Bring this one over. Then after which we just divide by 2 throughout will be this. Okay, there you go. This is the answer there. Then we look at part C. Find the solution of f prime x is equals to g inverse of x. So I'm just gonna f prime x. So f prime x will be, so f prime x, fx is essentially equals to ln 2x plus 1 Then what we're going to do, just outer layer, inner layer, just f prime x, that will be 1 over 2x plus 1 chain rule. Multiply it, and we'll get this and this over here. Alright, it's not too bad. Then what we're going to do is essentially just plug into this equation here, 2 over 2x plus 1. G inverse x, we need to find G inverse x. So G inverse x we find, so y equals to 5x minus 7. Y plus 7 over 5 is equals to x. So we know that G inverse x is given by... Well, actually we could just... Okay, I'm not sure whether writing this will be okay. I think that there are more than one way to solve this. So I'm just going to use this method here. I found G inverse x. Then I'm going to just chunk this in. Okay, so essentially this would be my fx. F prime x, then my G inverse x would be this over here. Okay, then I'm just going to cross multiply and solve this. So 2 times 5, x plus 7 multiplied by 2x plus 1, 10 equals to 2x squared 14 plus 2, 16x plus 7. So 0, 2x squared plus 16x minus 3. Alright. So this case here, what I'm going to do is actually just bring up my calculator. And I'm going to solve basically for polynomial equation. So just solve it and hope that you see there's any roots there. No, thankfully there's... Oh, sorry, I think I came wrongly. So it's 2, 16, and negative 3. Do they need exact value? I think there's a careless mistake here. This is 14, so this is 15. Alright, so sorry. So 5x. There you go. Great. So what we're gonna do is just keying it again. Then that will be... Alright, so we have 2 values here from calculator. Do they want the exact? They didn't want the exact, right? Okay, they didn't want the exact, so I'm just going to put this as minus 15 plus minus square root of 15 square minus 4, 2 times negative 3 over 2 square. Okay, I like to just use the formula to pretend that I actually found the roots without using calculator. Then after which, what we need to do is check that this over here, just write 0.1949, 0.19493 or negative 7.6949. Okay, now the thing is, we may need to reject one of the what do you call it, the roots here, and look at this over here. X is at least negative half, more than negative half, sorry, not at least. So essentially we can't fit the negative in, so reject as x is at least negative half here. So hence x will just be 0.1941195. Okay, so it's super important to be able to, I think that's the reason why yeah, they ask, they put a domain there and ask you to find a range to know what input values of x could be input into the equation. Let's look at question 4. I think question 4 is interesting too. So fx is a cubic expression. Find possible expression of fx. Oh, okay, great. So what I'll do is essentially, knowing that my expression here could be a x plus 1 root, so alpha x, okay, maybe I just minus, so fx is equals to a x minus alpha, x minus beta, and x minus gamma. Maybe this b, I'll just put this as k. There's a multiplier effect in front. Okay, so modulus fx would give us essentially k. The k can be I think I would rather put the k positive, negative. All right, that's the main thing, because the roots are pretty straightforward. This is 1 alpha will be minus 2, beta will be 1, and this is gamma equals to 3. Right, so we know that fx is essentially equals to k equals to x plus 2 because alpha is negative 2. So if you substitute this, it will be plus a 2. Then x minus 1, and after which x minus 3. Not an issue. So you put a then we know that essentially when x is equals to 0, fx modulus will be 24. So in other words, we know that there will be a possible, so I'm going to put this fx k, so 0 minus 1, 0 minus 3 equals to 24. Wow, it's a lot of, so k, so this will be 2 multiplied by -1, -3, so will be 6k 24. So modulus k divided by 6 throughout will be 4. Okay, so we know that k is equals to plus minus 4. Essentially, we have two possible expression here. So two possible expression will be fx equals to, can I just put, I could just put plus minus 4 in front. 2x minus 1, x minus 3. Okay, so plus minus 4. Okay, great. So that's part 4a. The possible expression I've written down too. So on the axis below, sketch the graph of y equals to 2x plus 1 and graph of 4x minus 1, setting the coordinates of the points where the graph meet the coordinate axis. Okay, great. So let's look at the first one. I think the main thing is to write down the minimum point if you can. So this case here, I know that the minimum point will be, this will be 0 minus half and 0. Okay, so minus half, maybe I'll then, whereas for this case, this is a mean point. Then after which for y equals to what, 4x minus 1, the mean point will be 1, 0. But this is steeper, right? The 4 would suggest it's steeper. So I think I will draw to scale because it will help me, right? How do we draw it properly? So the thing is, you just take a ruler and measure this out. I'm just going to measure it roughly. Then after which, I know that this is like, this case here is minus half. Then this will be half and 1, and this is -1. Alright, so when x is 0, this graph would give us y equals to, just substitute 0 in, so 2 times 0 is 0, so obviously this is 1. So I'm going to just put a 1 here. Okay, so this over here is where I'm going to draw my V shape. You know that modulus graph will look something like that, right? So you just do this, and afterwards you just do this. So this is the first thing that I would do, is to, yep, draw it up. Then that will be y equals to 2x plus 1. Great. The next thing is minimum point is 1, 0 for this. So I know that it will pass through. Okay, I'm going to use another color. So it's here. But when x is 0, we know that y is equals to 4. 0 minus 1 is -1. But what we'll get is essentially just 4, right? So you'll pass through 0, 4. So 0, 4 is 1, 2, 3, and 4 here. So you pass by here. Okay, so you can see that actually is much deeper. So this case here will be like 1.5 is 3 over 2 and 2, right? So this case, just maybe I'll just move this to the side here. Then I'll just draw this up. This over here, I know that it will be a V shape as such. I'm going to draw it. Okay, there you go. So roughly it will be here to 4. Then after this is steeper, here to here. It seems like I don't have enough space, but this guy would actually intersect at this juncture here. Okay, but this will not what do you call it? It will not intersect. It will be at the other end there. I may have underestimated or overestimated the graph there, but that's the case. So you have to make sure it intersects. Maybe I just I'm gonna make this whole graph smaller. There you go. Make the whole graph smaller. Then after which you just label this graph here and label this graph here. Just a good practice to just label them. It would be y equals to 4x minus 1 modulus. Great. That's a graph that I am looking at. Of course, we need, I think that's about it. Yep. So let's get the next one. Find the exact solution for this. I think this is pretty okay. Finding the exact solution for the modulus, we know that when we open up the modulus equation there will be plus minus 4. Oh, sorry. I think I'll just 2x plus 1 goes to modulus 4x minus 1. So 2x plus 1, we know that this is plus minus 4x minus 1. Alright. Then this case here, what we get is actually 2x plus 1 equals to 4x minus 1 or negative 2x plus 1 equals to negative 4x minus 1. That will be 2x plus 1 equals to 4x minus 4, after which we get 2x equals to 5x equals to 5 over 2. This case, 2x plus 1 equals to negative 4x plus 4. To be 6x equals to negative 3, x equals to negative half. Now, take a look at your graph. Oh yeah, they intersect twice actually. But how come they do not intersect that half? Did I make some mistake there? Yes, I did. So this is half. There you go. 4 minus 1 is 3. So 3.5. So there you go. There are two intersection points here. So we know that thankfully I drew to scale. So we can see that one of it is half. And here as well. Find the exact solutions. I think that's about it. So this case here, x is equals to 5 over 2. Can I leave it in fraction? Yeah, I'm not very sure you can leave it in fraction or not, but I'm just going to leave in decimal, right? There will be 2.5. So half or 2.5. Right, great. That's about it. So let's look at question 5. Find the vector which is in the opposite direction of 15 minus 8 and has a magnitude of 8.5. So if this opposite direction, we know that it will just be parallel to negative of this, right? So this is negative 15 and 8. Then we just need to find the unit vector. The modulus of 15 minus 8 would be just using Pythagoras theorem, plus minus 8 square. King calculator be 15 square. To name an exact value, I do not know. Okay, 17. Thankfully, this is 17. So essentially, the vector, required vector, is just 8.5 multiplied by 1 over 17, because the unit vector of this vector would need to divide by its own length, right? Its own magnitude. So maybe I just put the 8.5. That's 15 over 8 divided by 17. So this is the answer there. So 8.5 divided by 17, there will be half. Oh wow. So that will be half 15, negative 15 over 8. Right. So that is how I will do it. Then find the value of a and b. I think this is pretty okay. So two unknowns. So two linear equations is required. So this is multiply it in 5 times 3 is 15a, 5 times b is 5b, after which plus 2a plus 1, 2, 6b plus 6a, 12. Just distribute it in. Remember, distribute it in. 6 times 2 is 12, right? So then what we get is 15a plus 2a plus 1, 15a plus 2a plus 1. Then the denominator 5b plus 2, 6b plus 6a, 12. Okay. So of course, what we're going to do next is essentially just take out the, what they call it, the simultaneous equation. We're going to take each component out. Then what we get is 15a plus 2a plus 1 equals to 6b plus 6a. 5b plus 2 equals to 12. So this case, I think this from this second one is pretty interesting because just solving it, 5b equals to 10, so b is equals to 2. So substituting 2 into 1. 2 into 1, what we get is, this is maybe 15a, so it's 17a. 15 plus a is 17a. Plus 1 is equal to 6 times 2 plus 6a. So 17a minus 6a is 12 minus 1, 11. 11a, a is equals to 1. So hence a is equals to 1, b is equals to 2. Alright, that's about it. So that's how you do this question here. So let's look at question 6. Write down the value of k for which the line y equals to k is tangent to the curve for sine x plus pi over 4. Oh, it's just writing down the value of k. So I think the thing now is that this is a sine curve. So we know that the curve here will have a line of equilibrium of y equals to 10 here. All right. After which, I'm not sure how it's going to be positioned. Don't really matter. Okay, but I know that the sine curve here that is translated. Okay, we know this, but I know that sine curve would somehow look like that. Then you know that this case here, the amplitude here is 4. All right. So this case, in order for you to be a tangent to the curve, and this is a horizontal line. The main thing is this is a horizontal line. So the horizontal line will have to be tangent to the curve. So it has to be the max point and the mean point. Right. So just write these two down should suffice. So let's just try it out. There you go. So the amplitude is 4 here. So this is 10. So in order to find the value on top, this is 14, right? So it's 4 plus 14. Then the amplitude is 4 below as well, so this is 6. So hence 10 minus 4 is 6. Okay, so this is y equals to 14, y equals to 6. So hence k is equals to 6 or 14. Okay, so it's just a sinusoidal graph. Okay, so you just need the top and the bottom. That's about it. Let's look at the next. Oh, this is pretty interesting. So we always start from the more complicated part. So in this case here, it's clearly the left hand side, right? Okay, left hand side. Let me just start this from left hand side. Now, I'm not sure what equation. Let me just see what formula is given. Also, we're given this 3 only. Okay, no additional formula. Okay. So let's just try these 3 identities there. Okay, come here. So from left hand side, what I'm going to do is you look at the expression here, this tangent and cosine, tangent and cosine. Of course, there's no double angle in the sense that this is theta and theta, so we don't really need to change the angle to the same stuff. But looking from the formula, there's no double angle, so likely we won't be touching the formula. On the left hand side, we only have sine. So what I'm going to do is I'm going to just break the tangent apart. Tangent theta is sine over theta, cosine theta, and after which 1 plus or minus 1 minus tangent theta over 1 plus cosine theta. Cosine theta. So 1 plus tangent is sine theta over cosine theta. Alright. Then the bottom, 1 cosine theta is 1 minus sine theta over cosine theta. That's what I'll do. Okay, cosine theta here. The next part is essentially I'm just gonna make it a common fraction there, common denominator, just a single fraction. So it's 1 plus sine theta cosine theta plus 1 minus, or this is 1 plus, so 1 minus cosine theta, 1 minus sine theta cosine theta. The denominator will be 1 cosine theta, 1 plus cosine theta. Alright. In this case here, slowly distribute it in. It looks very complicated. Let me see first. Okay, actually looks okay. Maybe I shouldn't have changed the tangent out first. I'll just change it later because this looks a bit complicated really. So I think changing it later will be better. So you could do it, but I think the better way is to change it at the very end. So we're going to make it a single fraction at the start. Actually, I'm not sure whether it's 1 minus cosine theta, then 1 minus cosine theta, 1 plus cosine theta. Okay, great. So the denominator is 1 minus cosine square theta. So not an issue. We know that from here to here, what you're going to get is a square minus b square is a minus b, a plus b, difference in squares. Then distribute this out, expand this out, tan theta plus cosine theta plus cosine theta. Tangent theta, can I just write it as sine over cos? Or maybe I just put it as tangent theta. Then this is 1 minus tangent theta minus cosine theta plus cosine theta tangent theta. Alright, so for the denominator, we know that this case there is actually just our typical cosine square theta plus sine square theta is equals to 1. So sine square theta is actually equals to 1 minus cosine square theta, right? So this is sine square theta, not an issue. For the top, we could actually cancel a few terms out. So this case, tangent theta and minus tangent will be cancelled out. Cosine theta can be cancelled out. We are left with cosine, 2 cosine. So it's 2 plus 2 cosine theta tangent theta. The bottom is sine square theta. So like we talked about at the start, is that the one on the right has a lot of sine and the one on the left got cosine and tangent. So I'm going to do is actually just change the tangent to sine theta, cosine theta. Okay, actually I could even factorize the 2 out. So factorize the 2 out. Is that what they want to do? Yeah, factorize the is 1 plus sine theta. Cancel the cosine is sine square theta. So right hand side. Okay, so that's how you do P part 1. Hence, we are required to solve this inequality here. I think this is pretty okay. So this one is the expression. It's a very standard question that I like to ask, right? So you just need to replace this in because that is what was given. So just put this as 2, 1 plus sine theta, sine square theta is equals to 3. Cross multiply it up to 1 plus sine theta is equals to 3 sine square theta. This is a quadratic equation here. So I will have 2 plus 2 sine theta, 3 sine square theta. So 3 sine square theta minus 2 sine theta minus 2 equals to 0. Now this case here, if you are not able to see sine square theta as an entity, you could just use a substitution method. Okay, so in other words, this is actually an entity. So what I'm saying is you have to be able to factorize this out like that. So I'm just key this in. Polynomial, then polynomial degree is 2, then with 3, negative 2, negative 2. That would be good if you're able to see that, right? So you can just factorize it out like that. So this case here, or if not, so sine theta is equals to minus 2 plus minus b squared minus 4ac, or not, you just let y equals to sine theta. Then you know that this is 0 equals to 3y squared minus 2y minus 2. Alright. Then y is equals to minus b plus minus b squared minus 4ac over 2a. Then I think you just copy the answer from the calculator. Alright, just so this case here, we'll get is 1.21525 525 or negative 0.54858. Alright, so That's our sine theta. So what's the main thing to understand is that sine theta is always between 1 and -1. So this, you have to reject this because this is the value bigger than 1. So in this case, they'll reject as -1 between sine theta between 1. Okay, so we know sine theta is equal to this. So there are two quadrants which sine will be negative. Quadrant number 1 is, so I'm going to write the basic angle first. Basic angle will be, I'm going to use a reference angle. So sine inverse, just put the positive value. Basic angle, okay, just put a positive angle there. So it's 54858. That would be 33.269. All right, then degrees, is this in degrees? Make sure your calculator is in degrees, all right? Then what I'm going to do is just know that sine is negative for quadrant 2, quadrant 3, and quadrant 4, ASTC. So ASTC, sine is negative, and sine is negative here. Okay, so we are looking at 360 plus 33.269 or 360 minus of 33.269. So essentially the angle that we're looking at is this angle here. This angle here. So this is your alpha. This is 180 plus alpha. This is in quadrant 3. So if this is my basic angle, then I need this to be here. So this is 360 minus alpha. Okay, key in calculator. Should be able to get the answer there. So it's, what am I doing? 180. Sorry. So this is 180 here. That'll be plus 180, 213.3, 213.3, or 360 minus of 326.7, 326.7. This is all in 1 dp. So angle usually you leave in 1 dp. All right. Let's look at question 7 here. So the first three terms of an AP are given log 3, 3 log 3, and 5 log 3. Given that the sum to n term of this progression can be written as 256 log 81, find the value of n. So essentially, what we're going to do is actually just understand that if you're given is AP, so log 3, 3 log 3, and 5 log 3 here, what we're going to do is actually just plus d here. Okay, there's a common difference here, we know that. So essentially to find the d, what we just take the two consecutive term, the subsequent term minus of the previous term. So essentially what we get is log 3 minus log 3. Okay, the first term is just log 3. We know that a is just log 3. So for 3 log 3 minus log 3, just don't worry. This is the same as 3x minus x, which is, we'll get 2x, right? So 3, you see the log 3 as an entity, so this will be 2 log 3. I think this is okay. Okay, we have the d and the a here. So we know that Sn is equals to n over 2, 2a plus n minus 1. D, I think, is given in the formula, right? So let's look at the formula there. Sum of the first n term is, there you go, n 2a plus n minus 1 d. So this case here, what we'll get is essentially just putting all the values we've given. So 256 log 81. Okay, n over 2, 2 log 3 plus n minus 1 log 3 over here. Okay, after which what we do is we're gonna just expand it in. Oh, d is 2 log, sorry. D is 2 log 3. So expand it in. Then we'll get is n over 2 log 3 plus 2n log 3 minus 2 log 3. So these two are the same quantity. So minus off will be 0. What is left behind is just n over 2 2n lg3. Okay, there you go. Now I would like to draw attention to, okay, this is log 81. So 81, if we prime factorize it, this is 9 multiplied, 81 is 9 multiplied by 9, which is also 3 squared times 3 squared, which is 3 to the power 4. If you prime factorize it, you could do that. So of course you can use a calculator to solve this, but I'll just practice some of our logarithms. So I'm just 3 to the power 4 here for 81. Then this 4, what I could do is actually just multiply using the logarithm rule, bring it down. Okay, so this case there, okay, it's 256 multiplied by 4 log 3 here, and this is n over, okay, then I can cancel this, and I'll get n squared log 3. This case, what we can do is to just divide both sides by log 3, and 256 times 4, so it's 1024 equals to n squared. So obviously n cannot be a negative value, so I'm just going to take the root of the positive root of 1024. That will give us n equals to 32. Okay, is that it? We need to find a value of n. Okay, so that's how you do this question here. After which we have got part B. So we were told not to use calculator for this part of the question. Find the first 3 terms of a GP. The first 3 terms of a GP are given by ln 256, ln 16, and ln 4. Find the sum to infinity of this progression, giving your answer in the form of p ln 2. Now the power here is actually the base. Basically the power here that we're using is 2. So we need to rewrite this if we could. 256. I think this is 2 to the power of, we could check. I know that 16 is 2 to the power of 2 to the power of 4. This is 2 to the power of 2. Okay. 256 will be 2 to the power of 8. Alright, so we at the get-go you could just rewrite them. So these are the first 3 terms, ln 16 and ln 4. So I'm going to rewrite them into ln 2 to the power 8, ln 2 to the power 4, and ln 2 to the power 2. Alright, then why do I rewrite this? Because I could bring these terms down. It'll be easier for us later. So these first 3 terms could be rewritten as 8 ln 2 and 4 ln 2 and 2 ln 2. Alright, that's what I'll do. Usually we'll rewrite them first, and it'll be much easier. So this case here, the common ratio, which is the multiplier for each term. So I'm gonna just write this is multiplied by r, right? Will be just 4 ln 2 over 8 ln 2. So this case here, we'll cancel it away. This will be 1 over 2. Alright, so r is just equals to half. So the sum to infinity is a 1 minus r. So the a is, similarly, I'm going to just use 8 ln 2. So a is 8 ln 2. This is my a. This is my a. Alright, this is my a. So a is 8 ln 2. Then the denominator, I'm going to do 1 minus half, and I will get 8 ln 2 divided by half over here. This case here, I could do is just multiply by 2, multiply by 2. Now, when you multiply by 2, please do not multiply the 2 with the 2 inside the ln. It's actually to the outside here, so it's 16 ln 2. Okay, so this is the sum to infinity for this question here. So this is the answer that we're looking for. Let's see. The next question would be, do not use the calculator as well for this part. Find the exact coordinates of the points of intersection of the curve and the line. Okay, I think we could just substitute it in. So substitute y equals to 3 root 5x plus 10 into y equals to x squared plus 2 root 5x minus 20. So I think this is just algebra. Equate both sides, so it's 3 root 5x plus 10 x squared plus 2 root 5x minus 20. Bring it over to the other side. So what I'm going to do is x squared plus 2 root 5x minus 3 root 5x minus 20 minus 10. Okay, so this is bringing from the other side. This is minus 10 as well. This case here, remember certs, same thing. Don't get too worried about it. See this as, this is 2. So see this as an entity. They are the same entity here, root 5x and root 5x. Okay, so you see it as 2 of something minus 3 of something, okay, or 2a minus 3a, which is actually negative a, right? So essentially this part here, what we get is 2 minus 3, which is minus root 5x minus 30. All right, so we need to solve this question, solve for x without using calculator. So we're going to use the formula minus b plus minus b squared minus 4ac over 2a. All right, so this case here, we get root 5 plus minus 5 minus 4 multiplied by 3, that will be plus 120. So it's 125. So root 5 plus minus 125. I think 125 is 25, is it? Square root 125. Oh, sorry, it's not. It's not 25. 625 is 25. Yes. Okay, so 125. Similarly, this case there, it looks so prime factorize it. Always prime factorize your number here. If you're too concerned, what you do is just take 125 here. 125 divided by 5, then divided by 5 again. You realize it's 5 to the power of 3. Okay. So this case there, what we get is root 5 plus minus 5 squared times 5. Okay, 5 to the power of 3. So you can square root it. Root 5 plus minus root 5 square, root 5 over 2, then this will be root 5 plus minus 5 root 5 for 2. Okay, that will be, so essentially it will be 6 root 5 plus 5 root 5, or root 5 minus 5 root 5 over 2, 5 plus 1 root 5. So 5 root 5 plus 1 root 5, that will be 6 root 5, right? Then after which, or we have got negative 4 root 5. So when you simplify them, this will be 3 root 5 or negative 2 root 5. Okay, pretty okay, I think. Then I think that is pretty okay, because once you've gotten the x, you replace it back into the y, it will be much easier. The y was just, so when x equals to 3 root 5, our y will be equals to 3 root 5x, 3 root 5 plus 10. There will be 9 times 5 plus 10. 45 plus 10, that will be 55. Okay. Then I'm going to do the other one, which is when x equals to minus 2 root 5, we have got y, 3 root 5 minus 2 root 5 plus 10. That will be minus 6 multiplied by 5 plus 10 minus 30 plus 10, which is minus 20. Do we need to find the exact coordinates of point? So point of intersection, coordinates of points, intersection, 3 root 5, 55, and negative 2 root 5, negative 20. Okay, So that's it. So they want the coordinates, so they just write it in the coordinates form. All right. Let's look at part B. So it's given that tangent theta is root 3 minus 1 over 2 plus root 3. Find the cosecant square theta. Now, if you look at cosecant square theta, the first thing you must understand is the only way to relate tangent and cosecant square theta is through cot. So essentially, cot square theta plus 1 is equals to cosecant square theta. All right. So cot. So we know that cot is actually 1 over tangent theta. So cosecant square theta is equals to cot square, which is 1 over tangent theta square plus 1. Alright? So take the reciprocal of tangent theta. So we know that cot 1 over tangent theta, we just take the reciprocal, is root 3 over root 3 minus 1. So this will be 2 plus root 3 over root 3 minus 1 square plus 1. So what we do is, I think this is pretty okay. We're going to just expand this. That will be root 3 square minus 2 root 3 plus 1 plus 1 square. It's just you using a minus b square, a square minus 2ab plus b square. Right, the formula there. Then similarly for the top, we will use the a plus b square formula. The expansion here will be a plus b square is equals to a square plus 2ab plus b square. So here, what we'll get is, this is a plus b square. Okay, so this case here, we'll get is 2 square plus 2ab plus root 3 square plus 1. Okay, simplifying it, we'll get is 2 square is 4, 2 times 2 is 4, so plus 4 root 3. Root 3 square is 3, so there's root 3 there. Then this is 3 minus 2 root 3 plus 1 plus 1. So ultimately 4 plus 3 will be 7 plus 4 root 3. That will be 4 minus 2 root 3 plus 1. Okay, actually what we could do is we could we don't need to make it a single fraction. What we do, I'm going to just multiply by the conjugate sets here. So this is multiply by 4 plus 2 root 3. 4 plus 2 root 3. Okay, now don't forget about the 1 there. So this case plus 1 over here. So this case, what we get is 4 square minus, this is a difference in square, a minus b, a plus b, so it's a square minus b square. So the top will be just distribute it in. Okay, I'll just distribute this in here and here and here. Okay, so this case will be 28, 14 root 3 plus 16 root 3 plus 8 root 3 square plus 1. Okay, so what I get is 16 minus 2 square root 3 square, which is actually 4 times 3. The top could just simplify 28. 14 plus 16, that will be 30 root 3. Then this is root 3 here. 8 multiplied by 3 will be 24. Okay, and this is plus 1. So the denominator 28 plus 24. 52 plus 30 root 3. 16 minus 4 times 3 would be 4 plus 1. So this is 52 over 4 plus 30 over 4 root 3 plus 1. Simplifying 52 divided 3. 4 is 13. 30 divided by 4 will be 15 over 2 root 3 plus 1. So this will be 14 plus 15 over 2 root 3. Okay. Is that it? A and B are constants. Okay, in the form of this. Okay, there you go. So this is my cosecant square theta. This is it. Great. Okay. Let's look at the next question. So a circle of center O and radius R has a sector of OAB, fixed area of 10 square centimeters. Angle OAB is theta radians, and the perimeter of the sector is P. Find an expression of P in terms of R, okay? I'm just going to try and understand the question here by redrawing and what they are saying. OAB, so there's a sector here, OAB. This is theta. Fixed area of 10 cm square. So let's say this is 10 square centimeters, and O, and this is R. OAB. So this is OAB. The angle AOB is theta radian, and the perimeter of the sector P expression. Okay, so I think find expression of P in terms of R. So we know that the perimeter of the sector will be the arc length here, which is R theta, right? This is R theta. So in this case here, what we know is perimeter is equals to R theta plus 2R. Okay, so the perimeter is, you add the R, there are 2R here and R theta. That's it. But the problem now is you want P in terms of R. So we need to get rid of this theta here. Theta is not in terms of R, right? So we're going to make use of the area there. So area of sector, we know that is area of sector is actually half R square theta equals to 10. So just manipulate that, right? So I'm going to just manipulate that so that I could get theta in terms of R. This will be theta equals to 20. This is multiplied by 2 divided by R square. So 20 over R square. So since theta is equals to 20 over R square, we know that this is R, 20 over R square, perimeter. So perimeter is equals to 20 over R plus 2R. Okay, so 20 over R plus 2R. Let's go to the next part, which is find the value of R which P has a stationary value. So at stationary value, okay, we know dP dr will be equals to 0. So P is equals to 20 R negative 1 plus 2R. So dP dr is minus 20 over R negative 2 plus 2R. You can write this as dP dr is equals to minus 20 over R square plus 2R. So all we need is stationary value is that at that juncture, we need it to be equals to 0, right? So that will be, this will be 0 is equals to minus 20 R square plus 2R. We have bringing over R square equals to 2R. There will be 20 to R cube. R cube equals to 10. Okay, so this case here, find the value of R. I get cubic root of 10. So R is equals to cubic root 10 cm. Let's dP dr Ix. Differentiate this will be nothing square. Then this is R square equals to 10. R is equals to square root 10 cm. Okay, so that's it. R equals to root 10. Determine the nature of this stationary value. I think we could just use second derivative test. So let's do that. So second derivative test will be dP dr. So I'm going to differentiate from here. Okay, easier. So d square p dr square will be 40 r negative 3 plus 0. So this case here, this is obviously when r is equals to root 10. This is positive, right? Because d square p dr square is 40 over square root 10 power 3. This is positive. So hence, p is minimum, right? P is minimum. So since this is positive, P is minimum. Okay, P is minimum. Find the value of theta at this stationary value. I think it's pretty interesting. So R is root 10. So theta, we know we're going to use this then. Okay, because we need to find theta there. So half R squared theta equals to 10. Half R squared theta is equals to 10. So this will be half times 10 So tensor theta equals to 2. Alright. Yep, that's it. That is just it. So that's how we do this question here. Let's look at the next one. Question 10. Let's see how I can do this proficiently. So we are given that the normal to the curve y, tangent 3x plus pi over 12, at the point P with coordinates of P negative 1, where P is given by 0 to pi over 6, meets the x-axis at point A and at point B. Find the exact coordinates of the midpoint of AB. Okay, great. This seems like a long question here. I think we try and make sense of what's going on. We know that tangent curve looks like that, right? Okay, so it's something like that. So I'm not sure. We just sketch the curve to understand what's going on. All right. The good thing is we know that the gradient is always positive, so we can work something out like that. Then we are told that at P equals -1, so I think P equals -1 here, the point P. So because -1 is somewhere around here, y equals to, we try to understand the question. Y equals -1 will be somewhere here. Okay, so this has to be our P here. P comma -1. The curve here meets the x-axis at point A, and after which y-axis at point B. Okay, the normal meets there, so I'm going to draw a tangent here. Then the normal is a 90 degrees to this, right? The normal would meet, okay, maybe I just push this above. It will meet the x-axis at point A and y-axis at point B. Okay, great. They are told to find exact coordinates of the midpoint AB. Okay, great. Midpoint AB. So we know that A would be A comma 0, right? And B would be like 0 comma B. Okay. So I'm going to there's the first thing is I'm going to let it be, A be A comma 0 and B 0 comma B, right? And A definitely, okay, so I'm not sure whether A is positive or negative or B is, it's just the diagram here is just a guide. Okay, so I think the first thing is to understand that we need to find the value of P first before we even start. So I think this is 10 marks because there are a few things to take note. The midpoint actually is quite, by midpoint theorem, we essentially need the coordinates of A and B. We could do that. But at the same time, midpoint of AB could be easily settled by finding these two coordinates. But finding these two coordinates means we need to find the coordinates of P first. Because without the coordinate of P, we can't really find this gradient of the normal. Okay, so that's what we need to do. So what we're going to do is actually just solve for P. So for when y equals to -1, okay, we start off by y equals to -1 and x equals to -p. I know that substitute into y equals to tangent 3x plus pi over 2. We know that this will be -1 equals to tangent 3p plus pi over 2, right? Then after which, because the range of p is given by pi over 6, so take note, this is 0 to pi over 6. So 3p plus, so what we can do is just multiply by 3 first. We need to get this to 3p plus pi over 2. Then multiply by 3. What I get is 0. Just 3 multiplied by 3 is 0. 3p. This is pi over 2. Then after which we're going to just add pi over 2 throughout. Pi over 2. Okay, so this is our guiding domain that we're looking at. So it's pi over 2, 3p plus pi over 2. This is pi. So this case here is what we're going to find. 3p plus pi over 2 is pi over 2 to pi. Okay, so this case, find the basic angle first. So we know that basic angle with tangent inverse is always positive 1. Then tangent inverse 1 is we need the exact value. These are radians. So tangent inverse 1 is 45 degrees, which is pi over 4. Okay, so you can just quickly check your calculator. You tangent inverse 1, that will be 45 divided by 180, that will be pi over 4. So this case will be pi over 4. Do that. Then after which, what we need is obviously putting 3p plus pi over 2 there. Then we know that tangent is negative, ASTC. Draw it out. ASTC. We have got tangent negative in quadrant 2 and quadrant 4. So it's quadrant 2. Quadrant 4 is where tangent is negative. Then what we get is essentially in quadrant 2, this angle here, this is alpha, pi minus alpha. This angle here, this is alpha, basic angle. This is 2 pi minus alpha. So quadrant 2 is pi minus alpha, which is pi minus pi over 4. Okay, just pi minus pi over 4 is 3/4 pi. 2 pi minus pi over 4 would be 7 over 4 pi. Okay, so just take note. You just take 1 minus 1/4, 3/4 pi, 2 minus 1/4 basic angle for the fourth quadrant, 7 over 4. This is actually pi minus alpha and 2 pi minus alpha. Okay, great. Now then after which you need to examine which angle lies between this range here, pi over 2 to pi. If not, you need to add 2 pi to the angle to find. So we know that this actually is more than 1 pi. This is 1. 7 over 4 is definitely more than 1. 3/4 pi lies within it. So this is the angle that we're looking for. So in this case, 3p plus pi over 2 is equals to 3/4 pi. Then we have got 1/2. So 3/4 minus half, that will be 1/4 pi. This is 3 pi, so p is equals to 1 over 12 pi. All right. So essentially this p here, what we know now is essentially that this is p is now pi over 12 for our p here. So we can rewrite the coordinates of p is pi over 12 comma -1. All right. Okay, great. So that's the first one. Then after that, you're gonna find the gradient of the tangent. Then we find the normal gradient of the tangent. Then we find m1 multiplied by m2 give us a normal. That's pretty okay. So I'm gonna maybe use the next page here. So y is equals to tangent 3x plus pi over 2 dy dx will give us secant square 3x plus pi over 2 multiplied by 3. So essentially chain rule, outer layer, inner layer. So this case here, outer layer will be this guy, inner layer multiplied by 3. So this case here, what we get is m tangent is equals to 3 secant square 3x plus pi over 2. We know that m normal multiplied by m tangent is equals to -1. Then what we could do is actually just we take the reciprocal. M normal would then be this could be written as cosecant square 3x plus 2 pi over 2. Right? Take the reciprocal is quite okay. So this is 3. Okay, so take the m normal will be negative cosine square 3x plus pi over 2 3. So when x is equals to pi over 12, am I right? Pi over 12. Yeah. X, which is p, our m normal will be negative cosine square, which is cosine 3 pi over 12 pi over 2 square over 3. That would be 3 divided by 12 plus half. 3/4 pi in the middle. Square. Okay, 3/4 pi. Cosine 3/4 pi, mine is in degrees, so I will put 180, is actually negative 1 over root 2. So how do you do it? This is, you can square it, then it is half, right? So meaning to say this is negative 1 over root 2 as such, okay? Because they want exact, so you have to know how to churn out the exact out. So this will be 1 over 2 over 3, then we get minus 1 over 6 for the m normal. So in this case here, m normal is actually negative 1 over 6. Okay, now the thing about this is essentially we could find the line AB, the normal line, then we find coordinate of A and coordinate of B, or we could just use the gradient formula to find A and B. Alright, I think I will use the gradient formula to find. So A, gradient of, let's try this. So gradient of AP, right, is equals to gradient of m normal minus which is negative 1 over 6, right? Gradient of AP, we have A as A0, P is pi over 12 comma negative 1. So let me just write it down. A is A0 and P is negative 1 pi over 12. Sorry, pi over 12 negative 1. Pi over 12 negative 1. So then we just take y1 minus y2. So 0 minus minus 1. A minus pi over 12. Then cross multiply. So it's, I'll just get this as 1. A minus pi over 12 equals to minus 6. 1, 6. Then minus 6 equals to A minus pi over 12. So A is actually equals to pi over 12 negative 6. So A is pi over 12 minus 6 comma 0. Great. Then we do the same for the gradient of BP is equals to m normal. Actually, I think it would be the same if you find the line equation. So B would be B was it A0? 0B, right? 0B. So we do the same. So B minus minus 1 over 0 minus pi over 12 minus 1 over 6. Cross multiply. This will be B plus 1 minus 1 over 6 minus pi over 12 pi over 72 minus 1 B. Okay, so this will give us B is 0 pi over 72 minus 1. You want the midpoint. The midpoint would be the midpoint of AB. Midpoint, is it M? Okay, never mind, just let midpoint AB will just be, we just take the average, right? So pi over 12 minus 6 plus 0 divided by 2. 0 plus pi over 12 minus 1. Just use the midpoint theorem. X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. So this will be 2. A lot of steps involved. There will be 7, 24 minus 3, comma, set pi. 72 times 2 will be 144. Alright. So this is how I will get my midpoint. A lot of marks involved. So let me just recap. How do you do this part here? We first stop is to find the gradient of the normal at point P. But before finding the gradient at normal at point P, we need to find P first. So I think finding P there would already give you 2 marks based on answer scheme. Then after which we need to dy dx and then find the gradient of the normal, which will in turn gives you like 3 marks. Then equation of normal, you can sum it up or you can just use the gradient. Okay, I use the gradient way of solving it, but I think finding the equation of normal is also similar. It will probably maybe save more space, right? So that's how you do this question here proficiently. We have come to the end of our paper. Thank you for watching, and please remember to like this video and share this video with your friends if you find this video helpful. Remember to subscribe to our channel for future videos like this. And if you do need additional help, please do check out our IGCSE online math courses where students and teachers could learn in a safe environment. I personally will answer many of the students' questions there. Do check out the free mini course before signing up for the actual full course, where you can experience learning math in a holistic manner. So I'll see you online and see you in the next video.